Great. I'm going to go ahead and get started. If you joined after I said it earlier, I've added a link to this set of slides as a Google Drive download. I recommend getting it to play along. It's useful both for seeing what I'm talking about and for things like it has the password for the virtual machine. It has cut and paste commands from many of the tools that Twist, formerly BB&T. I've done a little bit of almost everything in IT and security at some point. I've been mostly recently focused on application security, but I've also done incident response, vulnerability management. I've done purple team engagements. I've worked as a web app developer. I've been a system administrator. I've done DevOps. I tend to be very enterprisey. Most of my work experience is really large organizations where we deal with tens of thousands or even hundreds of thousands of users, millions of users, and a lot of systems. So my perspective may be a little bit biased towards really large systems and enterprises that tend to be a little bit slower to move than some of the cutting edge stuff. The obligatory disclaimer, I am not speaking on behalf of Truist, BB&T, or any other entity. All the opinions expressed are my own. This is based on personal research, not work. All images used are believed to be a public domain. I'm using sample code under fair use. All content is copyright 2020 unless otherwise noted. If you have not downloaded these files already, I believe it's been listed as being related in the management system for the conference. But the upper link is the files for the entire virtual machine image. It's a .7z file, so you will need 7z to unzip it. I've provided the MD5 here. There's 3 different ways you can get the MD5 on Windows 10. You can use certutil. On Linux, you can use MD5, and on OS 10, you can use OpenSSL MD5. There's 2 reasons why it's a good practice to always check the hash when you're downloading files like this. The first is just a practical one. With really large files, it's possible that it will have gotten somehow corrupted or truncated in transit, and this will make sure that you've got the entire file. It's also a good security practice to verify that it's not likely in this case that someone was maliciously modified it, but when you're working with files on the internet where there's security implications, when you're taking something and running inside a virtual machine system like VMware or VirtualBox, theoretically they can attack your system through it. So you want to make process. The second link there is a background file that, as they talk, I did 2 years ago on web shells in general at InfoSeCon. I believe a link was also provided to a version of it that I did at DEF CON AppSec Village 2020 this year. It's got a lot of the background if you don't know a lot about web shells, on both what a web shell is and some of the techniques that you use to hunt it. Some of those techniques will be shown off tonight, but there's other things that will not be covered tonight, and we'll give you some additional background on some of the things you can do. So a disclaimer, the virtual machine contains malware. There's a bunch of samples that are downloaded from public repositories on GitHub that were written by various people. I have not validated that they operate safely. If you follow the instructions inside the labs, all we will be doing is looking at them. They will not execute. They will not do any damage or harm that way. If you know what you're doing, you're welcome to take some of these files and experiment with them, but be aware that they may do things like beacon out to the authors, or they may take actions other than what the user interface might indicate that they're going to do. It's not likely that that's going to happen with any of these files, but it is possible. It's always a best practice when you're doing something like analyzing malware that you didn't write, to make sure that you've got it in a virtual machine that's not connected to the internet or has a lot of security that isn't connected to like your bank account, that sort of thing. So again, I've done everything I can to make sure that this is safe, but don't assume that it's safe, and start, if you want to go more in depth than what we talk about tonight, definitely make sure that you have some good security practices. Pardon me for a second. I need to discipline my coworker, who's a lovely dog named Munu. So another note about the virtual machine is that it has an intentionally vulnerable web server on it. So it's easy to exploit it. It is bound, so it will only talk to connections from the local host. If you know what you're doing, you're welcome to change the networking so that you can connect to it from a different system. But if you have any risk of a bad guy being on your network, I don't recommend doing that. So a little bit about the labs. There's more than one way to do these things. If you know a way that's better or different and worth considering within reason, feel free to bring it up. We have everyone muted right now, but you should have the ability to unmute yourself. So if you want to interrupt during a slide, wait till I'm at a slight pause and feel free to jump in. Or there's also some Q&A at the end of each session, so you can bring it up then. The user account for the system is named lab, and the password is DC2020, all caps. The root password, if you want to start really getting in depth and modifying things, is DEFCON, all caps, is canceled with spaces in between the words. None of the labs require it, but if you want to start playing with something more in depth after the session, you're welcome to do so. I would certainly love feedback on this. You can send me Twitter DMs or send me an email at webshellhunting@joeschottman.com. So a quick note, do you have to do this lab tonight? This document, and again, there's a link to this document in the chat. If you download it, it will give you everything that you need to complete the labs. This is going to be a really dull, boring PowerPoint, which is what they tell you not to do, in that I will be largely reading it to you with some embellishments here and there, because I wanted to make sure that if you wanted to go offline, if you've got something better to do tonight, that you've got the ability to do so. If you have not downloaded the virtual machine and you want to do it some other time, you're also welcome to do so. The link to download it will stay live for quite some time. And if it should change, you can always shoot me a DM and I'll send you the new link. Again, because the content is pretty explicitly done in the text, if I'm going too slow and you want to just blow through this, feel free to mute the session and skip ahead, or just disconnect and go through all the slides, and it's all pretty self-explanatory, and you can jump back into the conference at the end if you want for some Q&A. If you don't know Linux, this is everything is Linux central. It's nothing too complex. In almost all the cases, I've provided commands that you can literally cut and paste, so you can do it step by step. You're welcome to do that if you're more comfortable with the command line and want to make sure that you get some hands-on experience rather than just cutting and pasting. You can look at what the instructions are and then use that to figure out what to do. So I wanted to give a couple quick notes before we get to the hands-on portion, based on some stuff that's been added since the talk that I gave in 2018. So briefly, what are web shells? They're malicious web applications installed by an attacker for remote access and control of a web or application server. Hopefully you've got some background on them already, because we're going to dive in pretty much directly to hunting them. But again, the PDF that I included as the second link earlier in the slide deck has an extensive amount of information about it. A few more notes that are in that slide, but were not in the previous version of the talk. Microsoft about a month ago started reporting that they're seeing a use of web shells that I've not seen people talking about specifically. That doesn't mean it hasn't happened, but it was new to me. I've included a link to the YouTube. It's mostly an advertising for their tools and services, but there were some interesting things talking about what the attackers were doing. So basically what they were doing is they got access to a system through, I believe it was either SharePoint or Outlook, and started pivoting around in the systems. They found the production web servers for the company, which were completely unrelated to the Microsoft infrastructure, and were providing information to customers. They pivoted onto that and went from using an ASPX web shell to a PHP web shell, because that's what that server was running, and then use that second web shell to start installing phishing documents. So they were targeting either the legitimate users of the company or targeting other users within the company to get their credentials by putting malicious documents onto the production web server. So it bypasses does this look like a suspicious phishing link, when it does in fact go to the legitimate company's server. So that was kind of new and interesting, so I thought that was worth noting. So there's also, asked Aquinas to take a look at this talk, and he suggested putting emphasis on the command execution. So in the previous version of the talk and in the slides, I talk about how almost anything that an attacker might want to do can be programmed in the web shell's native language. So if you want to open and read a file, you can use fopen type things and read in a file that way. But people, both developers and attackers, are kind of lazy, and you also get kind of set in your ways. And oftentimes the people developing the web shells may not actually be the people using it. So when you're an attacker, you often have a certain workflow that's based on using the native tools on the system that you get used to using. And so you just kind of want to use them. Or you might be more familiar with Perl or Python and something like that. So you don't want to be writing bespoke commands in ASPX or whatever the actual web server might be writing. So rather than implementing that as native code, oftentimes there will just be the capability of running command shell things from the web shell itself. So to an extent, this is actually smart because it keeps the size of the web shell down. If you had code that handled all of the functionality for all the possible things you might want to do with every command line option that's available on, say, Linux system, OS X system, Windows system using PowerShell, that would be a really large file. And you want to avoid putting a really large file on the web server because that could attract suspicion. But it does give additional ways to detect it. So if you got a tool like sysmon configured, that can keep track of what processes were launched. So if you see that Apache is running or IIS is running, and all of a sudden it's spawning SH, it's spawning Perl, Python, PowerShell, that kind of thing, that's really suspicious. And that's definitely something that should be investigated. It's possible that your developers may also be similarly lazy to the attackers and be doing things like that. But that's the sort of thing that you could be doing threat hunting to find and taking that to management saying, look, there's this dangerous non-best practice that the developers are doing. We need to make sure that they're doing it the safest, best way. So a little bit on hunting. So a lot of what I'm going to cover tonight will seem very easy and basic, like almost duh, why bother? And frankly, it is. The great thing about having web shell hunting is some very basic strategies will work very well against them. It's a matter of practicing ahead of time in a controlled environment so that you will know what to do when it actually matters. Having been involved in incident response at various points, if you're dealing with something that you've never done before, you might have read about it, or you might be sitting there frantically Googling how to do something. You're not going to have the best results. Whereas this is a growing threat. The NSA recently put out a document saying that you have to be really concerned about web shells. Microsoft has put out repeated documents because they're getting increasingly involved in security operations saying that you have to be concerned about web shells. They're one of the really easy, powerful ways of getting data in and out of corporations, out of controlled situations. And so it's something that if you're on the defensive side, you need to be really aware of. And at the same time, if you're on the defensive side, being aware of what people will be doing to try to find this will be really useful to you in trying to avoid some of those detections. So if you get really intrigued by this and you want to go deeper into how they're actually used, this is a good talk. It's from the last DerbyCon last year, and it's showing how a real life APT used one. It was used in the Middle East, and there was a moment that stuck out to me when I watched it right around minute 28, where they said, unfortunately, we didn't have access to logs on those systems, so we lost visibility into what they were doing. A key point about why you want to be doing threat hunting on a regular basis is it helps find gaps like that. When you start doing hunting or conducting war games inside your environment, even if there's no sign of an incident, it'll help you. The first thing is hunting establishes your baseline. If you don't know what's normal on the day-to-day basis on your network, on your different systems, when something is abnormal, you're going to have very little chances of spotting it. Developers do strange things, operating systems do strange things. If you're not used to seeing what happens, you're not going to be able to pick out what's not there. Per the previous comment, it helps you find the visibility gaps. So if you conduct a purple team style exercise and all of a sudden you find that 2/3 of the systems weren't actually logging to where you think they were, you can start closing those, and that will help you find actual attackers when there's an issue going on. And it can help find anomalous things that could create a security risk. So when you're hunting in your environment on a regular basis, you may not find things that are being conducted by an attacker, but you might find that someone secretly put a Internet of Things device that has a vulnerability that you're unaware of on your network. And just seeing that traffic and seeing why is something reaching out to AWS from inside the system when we have no business reason for that. that sort of thing. That will help you narrow down and find these risks and eliminate them ahead of time. Successful hunt mission doesn't have to necessarily find an attacker. As long as you and the process for your hunting gets better as part of it, that is a goal in and of itself. So there's some career limiting words. There's little that's worse than having to tell your boss during a live incident that you can't access important logs or that they don't exist. I have friends that do IR that come up with this time and time again, that if something had just been logging or if it had been logging to the SIM, they would have a much easier time containing an incident. So that's part of why you do the threat hunting, why you start looking in your environment when you don't think something's going on, is to find out what the problems like that are. Before I get to the virtual machine, are there any questions?
You can unmute yourself.
Hey, Joe, I don't think we can reach your link. People are reporting they have to request access for it and wait on an email.
And actually, I tried to request it, and it just went ahead and said too many people have viewed or tried to download recently. It wouldn't let me download it.
Try that. Or try that one.
That's fun. It says this file is infected with a virus. Only the owner is allowed to download infected files.
So I see that Eric was able to download it, but Hans was not. Is that?
Yeah. Yeah, that's the trouble I'm having. Your second link brings it up for view, but it won't allow it to download. It says this is infected with a virus.
It's probably spotting one particular slide. Give me just a second. I will take out that particular part and
That part
finish up.
out.
Any other questions while I'm saving this? Also, I apologize for the side view, but with my giant monitor, there's not a good way of mounting a webcam in the front. The webcam built into the computer itself is a nostril cam, so I figured I'd spare you that horror. See if that allows a download.
Same problem. It said sorry, this file is infected with a virus.
One moment. Isn't doing stuff live fun? See if Dropbox has the same issue. So as far as the virtual machine, there's basically three things that will be used in the virtual machine. There's the terminal. We'll be spending almost the time in it. If you're not familiar with where Sanos puts things, it's under the Systems Tools folder under Applications. There's Text Editor, which is a graphic text editor. If you're not familiar with Vim and other text editors, you might want to use it instead. It's in the Accessories subfolder under Applications. And for the very last part where we'll actually be using Web Shell a little bit, there's Firefox. It's under Favorites or under Internet. So the first lab is going to talk about antivirus and keyword searching. And depending on how you want to do this, if you want me to bounce back and forth between the presentation and the results, I can do that. If you want me to just talk about what the different commands do and let you do it on your own to save time, that's also possible. I'm open to either. So this web shells master folder has a large collection of web shells that I pulled off of GitHub. I have installed CramAV on the system also. CramAV, if you're not familiar with it, is the dominant open source antivirus scanner. So if you do the -r, that just means recursively, and the / means in this current directory. And it takes a little while to run. So the purpose of what I'm doing this for while it's running is to show you that it does have detection rules for a fair number of them, but not all of them. So what we'll eventually see is that I believe it's around 60% of the files are detected, which is not bad. So you don't want to count on antivirus as being the thing that stops web shells from getting on your system, but having that little bit of extra visibility where it might be a 50-50 chance of something really stupid landing on your system and getting detected, that can be worth it. It also means that as you discover a web shell within your environment, you can create your own antivirus rules for it or submit it to your antivirus vendor and ask them to create a rule for it. The virtual machine has in the Dropbox link, it's page 3 or 4 has a link to download the entire virtual machine, which ironically does contain malware, and Google is not detecting and blocking that.
So I still got an issue downloading from that link. But if it at some point I'll just follow along and come back to it later.
So here it finally ran. So we've got a total scanned files 222, infected files 112. So that's about a 50% success rate. Not ideal. So we can do a little bit of investigation and see what it takes to evade the antivirus engine. So there's one that I know is 100% likely to be detected. So we use that as an example. And it's also, I chose it because it is small, because we're going to modify it. So this is what the code looks like. It's kind of a mixture of HTML and PHP, old school style PHP. So in some cases, the heuristic that they use to detect a web shell or piece of malware is just the name. So I'm not quite sure why it's running so slowly, because it should finish this pretty rapidly with one, but the spoiler is it easily detects that it's still the file. So looking at this, just looking at like the first page, what might we modify to see if we can get the antivirus to not detect it?
Probably want to remove that line that you're on. It has the name of it.
So you would think that that's obvious for an attacker to do, but I have literally found web shells at previous employers that all I did was search for the word web shell and I was able to find it. And again, in the interest of time, I will tell you that simply removing that one line is enough to cause it to not be detected. VM is out where you launch the Zoom meeting. In other cases of seeing AV evasion where it wasn't quite so easy and there were specific lines of code that were what they were looking for, and to evade it, it was as simple as splitting the line So adding the backslash that says continue this on the next line was enough to evade it.
I was going to ask you if there's a more finite way to do this than searching for text and comments. If there was like a module or a command that you might filter for instead.
So we'll be getting there in just a minute. So if you are trying to do evasion with this kind of thing, you can use the equivalent of binary search to find the particular line that they're triggering off of. And in some cases, it may be multiple lines together. So if you just cut the entire file in half and search the front half, search the bottom half, it'll flag either one or the other, and you just keep using that to narrow down which lines you need to modify. So it finally did finish running, and as you can see, it says 0 infected files. So not reliable, but occasionally better than nothing. So let's start looking at some keyword searching instead. There are 208 files that include PHP in the name of the directory. So we can use grep to look for a couple things. So like the word system is often used. So system is used to run commands on the system itself. So there's a lot of things checking to see if the function exists. So in PHP, you can restrict what functions are allowed. So they're going through and checking to see if there's the capability of doing that or not. Lots of systems. So that's fairly decent heuristic. Out of the 288 files, there are a total of 402 lines that match it. If we want to just look for the total number of files that match it, we throw in the -L flag here, and we see that's 112. Eval, again, used to execute commands. We've got 103 of those. Yay, pets. So again, we've got some pretty suspicious looking stuff here. In fact, it's even more evil looking than that other stuff was, because we've got this string rot13 gz base 64 decode. It's obvious that there's a bunch of stuff here that they don't want us to see. So in real life, you often get things where there's multiple levels in encoding. So like in this example here, it's base 64, but then it's gzipped. So it's 2 layers of encryption and or encoding that you have to deal with. In this case, it's both encoding, but in other cases, you'll actually have things like AES encryption and a key being passed in from the attacker to unlock it. So evil, 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 evil. And part of the hunting is getting used to seeing what your normal code looks like. It's possible that your normal code might have stuff like this, but in general, it's not going to. So whenever you start seeing giant chunks of base 64 like this, that's going to be something that you know is a pretty good indicator.
There was another text thing where it said modified by Goose. So somebody else modified it and put their nickname in it.
That's very common. So 2 of the most common PHP web shells are someone forked an existing one and, renamed it, took all the credit. And again, in the interest of time, I won't do all of these, but exec is another command that executes things, and the backtick is also used to execute things. So if you download the virtual machine, there's a bunch of things that you can start using to play. So actually, not in the interest of time, I'm going to show you the backtick because that's an exception. And granted, so all of these are in fact evil files, but not everything they're doing is precisely evil. So there are some frameworks that are genuinely legitimate for working with MySQL that do use the backtick. So in this case, yes, the file is actually evil, but you could have developers that are using this depending on how they're working with MySQL. So again, it's a matter of going through and establishing your baseline for what's normal. So this is all pretty standard, legitimate looking PHP in this case. C99 is one of those, is the forked web shell I was referring to, by the way. So let's take out SQL. And here we've got some pretty evil looking code. So and there's hundreds of files. The samples include ASPX, PHP, Perl, Python. So if you want to go through and read, you can start seeing what evil code looks like in different languages. So another really common thing is, like we saw previously, there'll be base64 decoding. So this is a simple regex that looks for things that mostly clear base64. So that's obviously pretty suspicious there. But for example, in the very top here, this is the part that was matching, and that's not actually base64 code. And so you can tune your ability to detect this by expanding or making your length that's required larger or smaller. So in this case, it is a minimum of 15, but no maximum. So if you go too small, you're going to get false positives because there's legitimate things that are just alphanumeric characters that will be that long. If you go too large, you're going to miss a few smaller things that could be important. So it's generally you want to start fairly wide, maybe 30, 40 characters. But if you're really concerned something is going on in the system, dropping it down to 15, you'll get more false positives, but you'll get things that you might miss otherwise. So what if you wanted to get more powerful than that? So Yara is a really great tool for hunting for malware, including web shells. It lets you do things that you can't do with just grep. So among other things, you can match for multiple strings. You can attach conditions such as the file size. You can add metadata to the results, such as the level of risk. So you might have a finding that says, this is probably suspicious, but not absolutely indicative of a compromise. But maybe if you get 5 files that have that level of risk, then it merits a hands-on inspection, whereas something with a 100% risk level, you'd want to get into. So a little bit of information about it. White space is not semantic. You can put as many spaces, tabs, whatever as you want. To run it, it's Yara, the specific rule that you want to run against it and the file to scan. One unfortunate thing is it doesn't let you say just run all my Yara rules. So if you've got 20 different Yara rules that you want to run against a single file or a file system, you have to have something that loops through and does that for you rather than just being able to do it conveniently from the command line. So this is an example of a Yara rule for the Predator web shell. So it's pretty simple. You give it a name as a minimum. There's 2 different strings that it's looking for, and pretty obviously there's a condition that has to have both. So in some cases, if you're trying to get specific attribution, like shell exec in and of itself might be suspicious as a Yara rule in and of itself. But if you wanted to say, I specifically want to find the predator web shell for whatever, then you want to get more granular, and panel access is something that appeared in just the predator web shell and nothing else. So a little gotcha with using it also. So if you're used to working the command line, you might think that you can just say Yara, the rule, and then start run against all files. So that's not actually what Yara does. Or it's a combination of how Yara works and how bash works. So Yara is never actually past that asterisk. Bash itself takes all the names of the file in the directory and expands it out as if you had typed every single file there. What Yara always does, sorry, to contradict myself, in the previous statement, you can run more than one Yara rule, but you have to put them one after another in the command line. And then the very last one is the file to look at. So this is treating every file in the directory as if it was a Yara rule. It loads the file 1945.php and tries to parse it as if it were Yara, and it's getting syntax errors and bugs out. So it's non-intuitive. They've had people complain and say, hey, could you add some error message handling this? And they just say, it's how bash works, suck it up. So if you want to run it on an entire directory, instead you use dot. That will get the results you're looking for. The downside is you can't specify which files to run against. So if you had a mixture of a lot of images in the directory, for example, and a few executable files, if you wanted to inspect the executable files, you would have to inspect all the images as well. So if you want to work around that, you can do some kind of scripting with bash, Python, Perl, whatever your weapon of choice is. In this case, it runs a lot faster than ClamAV, fortunately, and you'll see that it's actually detecting itself because the Yara rules do match itself. And when you run against a file that doesn't match, it doesn't actually print out anything. So if you run this Yara predator.yara against nshell.php, you actually just get no result. So it's a little confusing. It's nice that ClamAV has that thing at the bottom that says how many files it examined and how many matches it got, because the fact that it gives you an empty set could lead to misinterpretations. So this is what I just covered with the entire directory aspect. So we can look for a role that looks for base64 and the exec function in the same file. So Yara has a bunch of example options of what it can search for. So obviously we've been searching for strings. You can say search for this hex value. You can do XOR strings. You can do full regular expressions. It's a mostly Perl compatible regular expression engine. You can do the count of the strings. There's offsets, there's file sizes. So if you're looking for something that you know is between 800K and 1000K, you can set that restriction. For Yara, there's not a specific regex that you give, you just have a specially formulated string. So if you place it inside of 2 slashes rather than single quotes or double quotes, that says treat it as a regular expression. Because the slash is semantic in Yara, if you're looking for something with a slash within the regular expression, you must escape it with a backspace. It says backspace, but should be backslash. So what this is showing is the number of files that have both that exec and that regular expression. So that's part of why if you're looking for a kind of vague amount of evil, you can write a rule like this. It will find lots and lots of things. If you're looking for something more specific, the previous rule that was just for predator will help you find that one specific threat. So for example, when you want to do something really efficiently, you found a web shell in an environment and you want to check all of your environments for it simultaneously, you might write a Yara rule that detects just that and runs it everywhere. Whereas something like this is going to be more computationally expensive and take a while to run. So there's many pre-written Yara rules that you can find publicly. There's quite a few that are specific to web shells. It depends on how much trust you have for those authors, but there's not necessarily a good reason to reinvent the wheel. So going out and if you want to start playing with this, it'll give you both malicious files that are like malware as well as things that are web shells. And it's fun to play with if you're a geek like me at the very least. If you're in an industry specific Intel feed, like an information sharing group between people in similar industry, they will very often have private rules of, hey, we found this particular thing in our environment. We're going to do some information sharing with you. And so here's a private Yara rule that you shouldn't share with the public. So that can also be a good source for Yara rules. There are other things that support Yara as well. So for example, Tanium can do Yara rule searching. So it's becoming kind of an industry standard that's really useful for threat hunting. There's other tools like OpenIOC that will do the same sorts of things. So what we've looked at has been pretty simple tools. They don't take a lot of care to hide what they're evil, hide what they're doing. If you read the code, it's pretty easy, other than some of those double encoded things, to find out what they're doing. There's a really nice, really evil program called Weevily that's a lot more powerful, or technically Weevily 3. So what is Weevily? It's a polymorphic PHP web shell with a Python command line controller. So it provides shell access to the target. It has a SQL console for pivoting on the target. It can do HTTP and HTTPS proxying, so you can start browsing someone's internal SharePoint using it. You can upload and download files, spawn reverse and direct TCP shells, audit the target security. So it's got a simple vulnerability scanner, kind of like a dumbed down version of Qualys that will help find other things that you can do to escalate your privileges. It integrates with Meterpreter, which is used by Metasploit. It can do port scanning for other things on the target system and network. You can mount remote file systems using it. It'll brute force SQL accounts. Really powerful, really evil. And like many of these things, you can just go to GitHub and download it. They're apparently not as strict about downloading malware as a Google Drive. So one of the key ideas about Weevily is you will never use the same code twice. Every time you are supposed to use Weevily, you generate a new version of it. So if you were following best practices, if you had 30 different versions or 30 different instances running on the victim's network, each version would be substantially different. So to show you what I mean, so this is just saying, generate a new instance of it. Here's the password that will be used to log in. Here's the file that it will be named. So just looking at it, we can see it's two different sizes. And looking at the code, they're very different. In fact, if we use the command that literally shows you the difference, it basically shows you that the entire thing is pretty much different other than the part that says, hey, this is PHP. So this is done to make it harder to write rules to detect it. It's harder to have hashes, searches for that it's obviously very hard for anyone to look at it and understand what's even going on with it. Although, again, if you see something like that in your file system and your developers write code like that, you should probably consider an alternate employer. So when I was first putting together the slides, this is what it looked like. Again, this is different than what I got just now. Every single time you run it, it's going to be a little bit different. So you'd think it would be really hard to write a rule for that. But a fellow named Peter Matkovsky did a really good job. He's got a great blog if you want to start digging deeper into how to figure out this sort of thing. And despite the complexity of the code that it puts out, it's not that hard. So there's just a few number of strings that it's looking for. There's obviously the PHP. He found that there were two variables that always appeared, or very often appeared, either KF or KH. So that made it very easy. This monstrous regular expression is something that would often appear, as did this, is this. So basically, you look at the condition, it says it matches a variable called PHP. It says it has either 1 or 2, and then all of these others, and all of a sudden you've got a pretty good match. So fortunately, live demos always go well. So if I had correctly based this, I'm not sure where the error is, and I won't try to debug it right now. What would happen is it will detect both the 1 and 2.php files, and then you can also run it against all of the files in that PHP directory where we were earlier, and there's 0 matches for that. So it's providing a really good, really excellent match of saying, not only is this a suspicious file, but it's one that we know is dangerous because it's a really powerful framework. So if you're doing this in the virtual machine on your own, obviously I had some kind of mistake in the slide here. If you go to that medium file, you can find the full code and cut and paste that and be good to go. So that brings us to the end of this section. Any questions? So the bottom line is you can do a lot of really great hunting just using the shell. Getting really familiar with things like grep, sed, awk, that sort of thing can let you do really fast, efficient hunting for things. So if this is something that you are interested in or want to go into, getting familiar with those is really good. If you're working in a more Windows environment, you're not going to have the same commands, but PowerShell is ubiquitous now and you can do a lot of the same things, but it's a very different syntax. My work in the past has mostly been on Linux, so I'm not that familiar with the PowerShell, but you can also find examples of how to do threat hunting on the file system using PowerShell if that's what you're interested in. So some file system tricks. Again, going back to what I said earlier, a lot of the things with Slab are going to seem very simple, and they are. The examples here are kind of contrived compared to the real world applications, but the principles will hold true. If you do this now, or at least think about it now, when you actually have to face the situation, it's going to be a whole lot easier. So what this is one of the larger PHP files applications. It's a web trees. It's a old application that was designed for people tracking family trees. So what we see here is it's been installed from the same package. Everything's got the same modification time. Like I said, it's pretty large. There's 7,421 files within this directory and its subdirectories. So if your code doesn't normally modify itself, just looking at the modification time can be really easy as far as picking this out. You can look for files with the same modification day. If you want to be really specific, you'd get down to the minute in some cases. In case an attacker basically compromise it as soon as it had been put online. But for the most part, just looking at the day is granular enough. So this command here says how many files have been modified since the day after the deployment. Hey, look, a file easily and quickly pops out. So it's August 8th, 2020. Everything else was July 27th. So again, you would think it wouldn't be this easy, but sometimes it is. However, there's a concept called file stomping, which is used to modify this time. That's actually surprisingly easy to do if you're not familiar with how it works. So you can just use the command touch and it will update that. So if it's not obvious, this says we're modifying the date and we're setting to be the same value as everything else. Now, when we do that same find all the files that are newer than that, it finds nothing. And when you do the ls-l, it looks normal. The good news is there's a way around this. You can tell ls to use it, and you can tell the file system to use it, or use the find command to use it. So ext is a file system used by Linux. It has the modified time, which is what's displayed by default, and that's based on trust. And then it's got a separate time that's called changed. That's much more reliable. So if we use that instead, it still finds it. So it's one of these things that if you develop the muscle memory when it's not important, it's really useful, because in like day-to-day system administration work, I'm used to just saying find and newer modification time as the default. You know, when you're not fighting evil, when you're just trying to get work done, that's fine. But when you're actively hunting for evil and you see what something's actually been modified, you need to make sure that you're giving it that full flag. So the Windows file system has something very similar, slightly different. Understanding that sort of thing is important. The bottom line is with web shells, unless the attackers performed a system level elevation privilege, which they may or may not do to try to reduce the chances of getting detected, or there may not be a vulnerability on the system that lets them do it, they're bound to what the user level software can do. So they can use that touch command, but they can't go in and actually modify the changed date. And again, this is really simple. If you have a known good version of the application, you can simply run a diff against them. So this might be something you might pull a set of files off the system that you think are compromised, put it on a known good system. You might bring in another copy of the known good source and put it on the file system, and you can just simply run diff. So diff, if you're not familiar with it, is just show me the differences. And right now it's taking all the files in the two different directories and comparing them to each other. So while this is running, another similar thing that you can do is if you're deploying through something like a package manager. So if you're rolling up your own .deb files or your own RPM files, they will have the ability to say, hey, is this the same as the RPM that installed it? If you're using a DevOps toolkit that's able to install things, a lot of them can do things like spot changes like this. So what we see here is that it did the diff on all the files recursively, and it found something, and I didn't put in a full web shell, but it's something that just, it's suspicious. Again, it's our old friend here, shell exec, and just taking the two sets of source code, the known good and the suspicious one, will give you this type of information. So another thing you can do is, rather than just going line by line and comparing everything, you can simply generate hash values of all of them. You can store the hashes in a safe location. This obviously has to not be the same system in case that system does get compromised. Empirically go through and repeat the process looking for changes. This is very similar to, or basically what products such as Tripwire do.
Hey, Joe.
Yes.
You're getting some USB mic roboting going on here. I don't know if I don't think that's only me hearing you like a robot-ish.
Nope, give me just a second. Am I back?
Yeah, definitely.
Audio still good now?
Yeah, you're actually a little louder even.
Thank goodness for technology. So pre-generated a set of the good hashes so we can compare it. So you can easily generate a new set and compare it. So this is a little bit of a complex command that's am I back to robotic?
Just softer, that's fine.
So this says go through and look in this directory. Look at all of the types that are files, so you're not looking at the directories themselves. Then execute the command md5 sum. I love using this with find. If you do the dash exec, the file to execute, and then the left and right curly braces, followed by a space / semicolon, it takes every file name that it finds with the find based on whatever criteria you give it, and puts it in there as if you ran md5 sum at each of those. And then it just redirects it to a current hashes file. So there's a lot of ways of combining them. You can't use diff in this case because the two hashes were generated with different commands. So this is just something to be aware of. in this case, I intentionally made a mistake because these hashes were generated using a relative path. Whereas these have a complete path. But as you get familiar with Bash, there's really easy ways to work around that. So I love the program said, it lets you do normalization. So this column here is the number of times that something appeared in the two different files. So anything that has the number 2 there is the same file on both systems. Anything with 1 is the difference. So it's another easy way to spot that this file.php is different between the good and bad using hashes rather than looking at the individual lines of code. And if hypothetically you have a hash of a known bad file, if you have these generated lists of all of the hashes for the files in the directory, you can use that for hunting evil. That brings us to the end of this section. Are there any questions at this point? And also what the segment after this, which is the final one for this, is actually using a web shell. If you are not interested in seeing a web shell being used, we can cut this early. I know that it's been a long day for a lot of people, and I've had your attention for about 90 minutes, where I can do a quick run through of just setting up a simple web shell.
Okay, everyone. Do we have any further questions? Okay, press on.
Yes, DVD.
So to my earlier point that I had really on the talk, that most of what I've shown so far is genuinely malicious code that is bad stuff or not necessarily vetted. There's an open source project called Laudanum, which was written by a number of the people, many of whom are like the instructors at SANS, as an example of web shells that can be used for both testing purposes and demonstration. And that is actually pretty well vetted and safe to use. So what we have here is a pretty generic standard installation of WordPress. There's none of the WordPress vulnerabilities in it, but I did add a simple little mistake in something that the theoretical owners added themselves. It's outside of WordPress. It's not a terribly interesting site, being all dummy data. So here's something that's a little bit out of place. We'll come back to in a moment. This is the dog that I've had to break off and yell at least twice so far this talk. So as you're exploring a website when you're doing penetration testing or just being a bad guy trying to get in, you definitely want to go through all of these standard things they're linked to. But one of the standard things you do is also look for things that you're not supposed to find. There's a standard that is called robots.txt, which is used to tell indexing robots like Google, don't look at these files, or don't look at them at all, don't index them, various rules that you can do. And sometimes it's because just visiting files can have side effects. In other cases, you want to keep it private. And in this case, I made a typo when I was setting this up. So it's not actually maintenance.html, it's maintain.html. So when you're going through prepping looking for vulnerabilities, anything that they're trying to hide is probably going to be something especially juicy, and you want to take a look at it because either it's sensitive information or it might be something related to running the site. So looking here, there's obviously something that's upload image that gives you some kind of hint what it would be used for. Again, this is very contrived, but it's just as an example. So we've got this one PNG. So we get a success, but there's not really an indication of where it ended up. So exploring a little bit, going back to this, since this is obviously a picture that's not part of the standard WordPress, we might take a look and see where that's located. So here we've got a pretty, something that you probably could have guessed also, that there's a directory called uploads, and that's where the files seem to get deposited. So we can try uploading something that's not an image. So requirements.txt, pretty obviously not an image. So we see that there's some kind of bug because it's saying it's an image and lets it through and it's been uploaded. And it's been a long day, so I forgot the name of the file that we uploaded.
I think it was requirements.
That sounds right. So yep, that's the file that we uploaded. So this is laudanum. Laudanum, if you're not familiar with it, is a tincture of opiate. So looking it up on your corporate system could get you a visit from HR for either hacking or drug abuse rules. So they support a bunch of things. There's ASP, ASPX, Cold Fusion. Hopefully not too many people have to deal with Cold Fusion at this point, JSP, PHP. There's even a dedicated WordPress one, but I'm going to take a look at the PHP. So we've got a couple different ones. There's a generic one called shell.php. We'll take a look at that. So Kevin Johnson, as a point of information, was the original author or original co-author of the SANS web pen testing course, SANS 542. So here we see that there's an allowed IPs range that's useful in production, but we might want to completely bypass that. And also that you have to have a password. The passwords are generated by taking a SHA-1 sum. So we're just going to use the exact same password that they gave as an example. We've added that. Here's a code that says if it's an IP range that's allowed, and we'll just make that true. And what I should have shown you before doing this that I forgot to show off. So what happens if you even try to access it and if you have the IP range restriction turned on, if you're not within that range, it just gives a header HTTP 1.0404 not found, and it just looks like, you know, there's nothing there. And the way that PHP works and Apache works, this actually appears in the log. So there's not even a record that the program executed, as far as you can tell. If you're doing threat hunting in the logs, you just see that someone tried to access a file that didn't exist. You'll have got a success. And all of a sudden, we've got a shell running on the system. So this is pretty basic. Like I said, a tool like Weevily has a ton of functionality. This is designed more as a proof of concept, so you can start playing around with it, which is part of why I selected it. So there's all kinds of stuff you can start doing after this. I'm not going to go through all of it live. It's something that you can do if you start wanting to play with it. I'll give them some hints on what's possible. So there's a large collection of PII that's been added to the MySQL database. So if you want to start going down that direction, what you could do once you got this is either use part of the laudanum, which is specific to MySQL, or part of the way that WordPress works is in the web root. We've got this wonderful file, wp config. And help if I added the full thing. If you didn't catch what I did there, it actually has up and down arrows for completion, just like a bash shell does, which is a nice little convenience. So by looking through this, you can get all kinds of passwords and start doing pivoting and raiding around like that. You've got, hey, MySQL database password, and the password is summer 2020. I guess they haven't quite caught up to the times that since we're now almost approaching winter. You can poke around on other parts of the file system completely unrelated to the web. So the big constraint is you're only running as the Apache daemon, but anything that the Apache daemon can do, you can now start doing. So you can start pivoting around to the internal networks, reading files, you can add additional files. So a really common thing that they will do is you don't want to just drop one web shell because they can be found. If you can drop a couple of different ones, you've got more chances of one or two not getting found and being able to regain persistence that way. Any other questions at this point?
Any questions, anyone? Okay, we can go ahead and press on then.
So one other quick thing before we finish, I wanted to show. So this is setting up a netcat listener on port 5000, which you'll see that it's just kind of hung and it's waiting for the response. And that's because it's executing it using the shell. So we can use PS3 to, if you recall when I was talking about how it's very unusual to see these things executing things. There's a bunch of different ways you can see it at the command line, but PS3 is an easy one. So HTTPD is what Apache runs as, or is named under the Santa system. So we can see that there's this family here, that this is the parent listener. This is what the web shell is running at, or this is the parent Apache server. This is what the one that the web shell is actually running as. But then it's also running this command here, nc. So this is an example of how you can do that monitoring to see what sort of things are being forked by something like HTTP that should never normally be running nc, and use that as your detection. So there's no other questions. I appreciate your time. If you do download the full image and play with it, definitely let me know if you think that the labs need any tweaking, tuning. There's a bunch of things that you can try doing with Yara rules if you want to start exploring that. And just looking, if you think you're going to do this, looking at some of the different web shells and the different languages that are being run in your environment will start giving you some ideas of what evil looks like in those languages.
All right, well, we'd like to thank Joe for helping us out on tonight with this presentation.